day, ma'am. This is the question number 7. And to answer the question 7, we have a question. Given the following equation, derive the simplified canonical form logistic circuit. Show your solution in the conclusion. And we have given this formula, I mean, equation. And what we are tasked here is to find the canonical form of the given equation. In the given equation, we have x, y, and we have x prime z and then y prime. From the given equation, we are missing z prime, I mean z, y, and xz, which is not present in the given equation. And then from the given, we can find z and z prime, and then y and y prime, and then x prime, z, and z prime. And then to transform, I mean combine the uh, we have to what we have to find in the equation, the given equation, we will have this equation x y z plus z prime plus x prime z y plus y prime, and then y prime x plus x prime, and then x prime plus z. And then from this equation we can get the next equation, and by distributing the x, y, and z in the parentheses, you will get x, y, z complement, and then x, y, z, x complement, y complement, z, and then x complement, y, z, and then x complement, y complement, z complement, and then x complement, y complement, and z. And for the next is x complement, x, y complement, z, and finally x, y complement, and z. As you can see here, I have underlined the similar terms, and if we combine it, it will result to x complement, y complement, and z. And the resulting equation will be this. For the resulting circuit, it will be this uh, xyz complement plus xyz plus x complement, y complement, z plus x complement, yz plus x complement, y complement, z complement plus x y complement z, and then x y complement z complement, and then proceeding to the integrating it in the circuit. It will be like this. uh, Logisim. There we have it. I have created the circuit, but I will explain the process on how to create this. Since we are given the letters X, Y, Z, that will be our input, which will be placed here, and then the uh, seven gates here will be placed here, and we will be using, and since we can see the plus sign or the addition sign, and then we will connect the inputs. For the first AND gate, we have XYZ. We have an inverter here since we have a Z complement. And then for the next AND gate, we only have XYZ. And then for the next gate, which is X complement Y complement Z, we have an inverter from the X input and Y input. As for Z, we don't have an inverter because it doesn't have the complement sign. And for the next gate, X complement Y Z, X input has an inverter here, and then for the next AND gate, X complement Y complement Z complement, Z complement. the three of the inputs have an inverter. And then for the next gate, which is x complement y, I mean x, y complement, and z, y as the only complement. And then for the last AND gate, uh, we have x, y complement, and z complement. And to connect the 7 gates in the NOR gate, I mean uh, OR gate, it will have an input of 1. And last but not the least, we will have to
I
analyze
see.
the
Then
circuit.
y complement.
And to analyze this circuit, we will have to right click and then analyze the circuit. And from here, we can see the table of the table for the question 7. This is the true table.